Hey geometry students, today we're going to be talking about lesson 77, finding the surface area and also the volume of cones. We've talked about surface area and volumes about a number of our different three-dimensional shapes before, and today we'll look at yet another one dealing with our cone. Just reviewing a couple of the things that we've already talked about before that will help us in our definitions for today. First of all, what is a cone? Well, we all know what a cone looks like because we're used to seeing an ice cream cone. So what does that look like? You have a circle that's at the bottom, and then it comes up to a point that is at the top. So our textbook's definition says it's a three-dimensional figure that has a circular base, and it has curved lateral surface that connects the base to a point called the vertex. So that's just a bunch of words that say you have your circle at the bottom. The sides are kind of curved around the sides as it does come up to that point that's at the top, and here's what your cone looks like. Couple terminologies about our cone that we'll use in our formulas for today. First thing talking about our cone is the base. Well, what part of the cone is the base? It's that circular part where you only have one of them when it came to your cone. Another word, the vertex. We just looked at that word on the previous slide. The vertex is just simply the point that your cone comes up to. That vertex is always going to be across or opposite from the base that you have in your cone. Now, two things that we'll have to be careful of when it comes to our cone as to refer to which part that we have to use in the formula. The first thing is referred to as the altitude. Well, what does the word altitude mean? It means the height. So that's the exact same thing that we'll talk about for the altitude of a cone. The height always has to be perpendicular, which means it's going up and down. Where is it going up and down from? Is from the vertex right down to the base. And you can see that in the picture. The height or the altitude is going to be on the inside of the cone that we have. Now, if you have a right cone, what does that mean? That your cone is a right cone. The base and then your vertex at the top are right above each other. So if I was to draw from the vertex coming straight down, I would hit the middle of the base that I have. Well, another option that we have for our cone is that we have an oblique cone. Well, what does that mean? That a cone is oblique. It's kind of tilted a little bit off to the side. You have your base, but then the vertex is kind of shifted off to the side. So if I was to draw from the vertex coming straight down, I might hit part of the base, but I would not definitely hit the center of the base that we have. Most of the ones that we'll be talking about here are the right cones, but did want you to make you aware of what it meant that you have an oblique cone in your question. Now, the other thing that we have to be careful of when it comes to the height is called the slant height. We talked about our slant height when it came to our pyramids. Remember, the slant height was the distance from the vertex on the top going down the side of the triangles toward the base. Well, it's kind of the same idea as we're talking about the cone. It's the distance from the vertex headed down the side of the cone where you hit the base, and you can see that in my picture. So the regular altitude or the regular height is on the inside of the cone, where the slant height is on the outside of your cone. One other thing before we get into our three things about the cones that we'll be calculating today, the radius of a cone. Well, radius has to deal with circles. We know radius is from the center of the circle to the outside. So where would I have the radius of the cone is going to be the radius that's on the base, because the base is our circle that we have. The first thing that we'll be finding about our cone is the lateral surface area. So what does that word lateral mean? It means what you have on the side. So it's the total surface area that you have except for the circle that you have at the bottom for the base. It's just what you have going around the side of your cone. When it comes to the lateral surface area, make sure you get this formula in your notebook. The formula for lateral is pi r, and that's the letter L. We saw that same letter when we talked about our pyramids. The two pieces that you're going to have to fill in when it comes to the lateral area of your cone, the letter R, which stands for the radius. Again, the radius is part of the base. And then you're also going to fill in the L, which is your slant height, the distance from the vertex headed down to the base going along the side of your cone. Let's go ahead and work through two examples together. So if I were to look at this cone and I wanted you to calculate the lateral area, and we're going to be doing these in terms of pi. I would like you to do the same thing on your homework. We're always going to give our answers in terms of pi, regardless of what the textbook says. So here's my formula. The lateral is equal to pi RL. In order to calculate that lateral area, there's two things I have to fill in, the radius and the slant height. Both of those have been given to us in the picture. So now I have the lateral is equal to pi times 4 times 12. Just finish up with that arithmetic. 4 times 12 gives me 48. So my lateral area is 48 pi, and that's just the correct label at the end, inches squared, because you are talking about an area question when it comes to lateral area. Let's do one more just to make sure we understand how to correctly fill in our lateral formula. We're going to do the lateral area of this cone, and again, we're going to do it in terms of pi. Our formula for lateral, pi r L. Again, I need to know the radius and I need to know the slant height. So if I fill in our question, notice I have pi times 3 times 13. Now, the number 3 isn't in my picture anywhere, so where did I get the number 3 from? Notice in the picture, the 6 that I have represents the diameter of that base, going all the way across my circle. Well, the radius is what I need in the formula, and the radius is half of the distance of the diameter. Because the entire diameter was 6, that means the radius is going to be 3, and that's where I got the number in the formula. So 3 times 13 gave me 39, and my final answer for the lateral area would be 39 pi, again leaving it in terms of pi, and our label here is centimeters squared. So lateral area, just what you have going around the side of our cone. The second thing that we'll be calculating about our cones is the surface area. Well, kind of one of those duh definitions. What does it mean that you have the surface area? You have the area of the entire surface. So the surface area is everything that you see in your cone. It's what we have going around the side for the lateral area, but it also includes that bottom part for our circle. It's every single part that's on the outer surface of the cone. Here's your formula. Again, make sure you jot this down for me. The surface area is equal to pi RL plus pi r squared. We'll need the same two pieces of information. We'll need our radius, you'll need your radius, and you'll also need your slant height, just so you understand the formula. Pi RL, well, that was the same formula that we just did for lateral, because the lateral is included in the surface, and I also have pi r squared. Well, what does pi r squared gives us? It gives us the area of the base, and the base is a circle, so we're going to use our area of our circle formula. Let's look at a question together here. This one I just wrote out in words. It says to calculate the surface area of my cone, we're going to give it in terms of pi again. The slant height of our cone is 9, and the base radius is 5. I'm doing surface area, so I jotted down my surface area formula, pi RL plus pi r squared. Correctly filling in our two pieces of information. So I have pi times 5 times 9 for the radius and the slant height, and then plus pi times 5 squared. They did give us the radius on this question, so we didn't have to do anything special. Work with each piece individually, and then we'll put them together. So the first piece, 5 times 9, gives us 45. That goes with our pi. The second piece, 5 squared, is 25, so we have 25 pi. Now, these two terms are considered to be like terms because they both contain the letter pi, or the symbol pi. So what do I do to put those together? We just add the coefficients. 45 plus 25 gives us a sum of 70. So my final surface area is 70 pi, and the correct label would be centimeters squared. As you're doing the homework questions, you don't need to worry about doing like the centimeter squared or inches squared, but I did want to show those to you so you're familiar with them when it comes to like our standardized test or the SAT that you guys will be taking eventually. So far we've talked about lateral, that's just going around the side, our pi RL. We just did surface area, that's the entire outside of the cone, the side as well as the base, so pi RL plus pi r squared. The last thing that we'll be looking at here today with regard to our cone is the volume. What does it mean when I'm talking about volume? Just like we've done before with our other three-dimensional shapes, volume is what I can fit on the inside of our cone. And here's the formula you're going to follow. Again, last formula to jot down in our notebook. The formula for volume is 1/3 pi r squared h. Now, notice this one doesn't have that L for the slant height. It has the h for the height. The height, remember, was from the vertex coming straight down to the base, so that's on the inside of your cone. Well, the volume is the amount of space that you have on the inside. That's why I want to use the height here. The L, or the slant height, was on the outside, and the lateral and the surface area are on the outside of the cone. So hopefully that makes sense with the pieces that you're going to want to use. So again, the height, just make sure you're using the altitude from your vertex straight down to the base. Let's go ahead and finish up with this question, looking at how do we correctly calculate the volume of our cone. So I have the volume of a right cone, the radius is 4, and the height is 7. Because I'm looking for the volume, there's my formula, 1/3 pi r squared h. We have the pieces that we need for our radius and for our height. So filling those into our formula, 1/3 pi, then I have 4 squared times 7. We're going to follow the order of operations as we go to simplify this question. So exponents are first. So I have 1/3 pi times 16 times 7. Now, if I multiply 16 times 7 together and then try to divide by 3 or even in any order, it's not going to come out evenly. So what I want you guys to do on this kind of answer is go ahead and leave it as a fraction. So I wrote it as 1/12 over 3. That's the fraction that I would have. 16 times 7 is 112. And then the 1/3 gave me the over 3 pi, again, as our final answer. I don't have any labels on this question as to regard like inches or centimeters, so I don't want to give any labels to show up on the final answer. So make sure that you do correctly use those different formulas as you're doing your questions for your homework. Again, lateral pi RL, surface area pi RL plus pi r squared, and then volume 1/3 pi r squared h.